Now, our interest here is with compression members. Now, when we talk about timber compression members, we're basically referring to the design of timber post. Now, compression members basically include posts, columns, vertical wall studs, and struts in girders or even in trusses. So it is important to carefully uh, look at the straightness of the timber when designing those timber posts. Right? So the amount of bow acceptable for column members should be within a specific limit, normally 1/300 of the length. Right? So the bow limit should be 1/300 of the length. Timber post may be subjected to direct compression. Now it can be only direct compression where the loading is applied actually, or it may be subjected to a combination of compression as well as bending, depending on whether the load is being applied actually or eccentrically on the members. If you've got some degree of eccentricity, definitely you're going to have a bending moment induced in addition to the compression forces. When designing compression members, more specifically post, now post may also be required to resist lateral forces, right? Lateral bending that normally is the result of wind action. So these need to be taken care of in the design of those compression forces, right? So many of the structures in timber will have a post being subject to wind action, and you'll have to design the post to resist the lateral bending moment induced. The structural adequacy of an actually loaded post is determined by comparing the applied compression stress parallel to the grain with the permissible compression stress parallel to the grain. So you've got an applied force, you're going to determine the applied compression stress, and you're going to be comparing it with the allowable compression stress for that specific timber. Now, to start with, one has to determine the applied compression stress. Now, the applied compression stress parallel to the grain is obtained by dividing the applied load by the cross-sectional area of the timber. All right, so as you can see from the formula, the stress, the C, subscript C, refer to the compression stress, and PR refer to the stress being parallel to the grain is equal to the applied load divided by the section area. The applied load is normally denoted by capital F and the section area by A. Now, you have to bear in mind that the section area is normally the net area after deduction of any open holes or notches. So if you've got notches or holes within the timber, you have to take that into consideration and hence determine the the net area. Now, it is also to be noted that no deduction is necessary for holes containing bolts. All right, so this is not in the equation. So you just do not take the holes for bolts into consideration when determining the net area. For the section to be adequate, the applied stress must be less than the permissible stress, or the permissible stress must be greater than the applied stress. Now, the second part is the permissible compression stress. The permissible stress, again parallel to grain, is obtained by modifying the grade compression stress, again parallel to grain, by specific K factors, by specific modification factors that may apply to the situation. The first one, the first factor you might consider would be the K1, that is the wet exposure geometrical property modification factor. K2, wet exposure stress modification factor. And K3, load duration modification factor. Again, as it has been specified earlier, it depends on the situation. Timber posts as opposed to wall studs are not normally part of a loading sharing system as defined in British Standard 5268. Therefore, the load sharing modification factor K8 does not apply here.